crack the width of a pencil lead sank a floating platform the size of a city block and killed 123 men in about 20 minutes. And when investigators finally pulled the wreckage apart, they found something inside that crack that should have been impossible: paint. Hold that image, because this entire video is built around one question, and I am not going to answer it until the very end. What do a 1/4-inch weld in the North Sea, a broken window off the coast of Newfoundland, and a lifeboat hook in Brazil have in common? 3 different countries, 3 different decades of technology, 3 different companies. Together, those 3 small, boring, forgettable objects killed 249 offshore workers. And on the day each of them killed, not one of the 3 was covered by a safety standard. Not one. The rules existed for the blowout preventers, the gas detectors, the fire pumps, the big dramatic hardware everyone thinks about when they hear the words offshore safety. Nobody had written a rule for a bracket weld, a window, or a hook. By the end of this video, you will know exactly why that happened, why it stopped happening, and why the standards that fixed it are the most important rules in offshore oil and gas that you have never heard anyone talk about. And the answer is hiding inside that paint. If you work offshore or anywhere near heavy industry, stay to the end, because the pattern behind these 3 disasters is almost certainly sitting somewhere on your job site right now. Wearing the same disguise it wore in 1980. It looks like something too small to matter. March 27, 1980. The Ekofisk Field, Norwegian sector of the North Sea, about 200 miles offshore. Rain, fog, wind blowing hard enough to push the sea into rolling hills of gray water. Anchored beside the Edda production platform sits a 5-legged floating giant called the Alexander L. Kielland, a pentagon-shaped semi-submersible built in France and named after a Norwegian novelist. It was designed as a drilling rig, but it never drilled a single well. Instead, it worked as a flotel, a floating hotel packed with bunks, a mess hall, and a cinema, housing the workers who ran the platforms around it. On this evening, there are 212 men on board. Their shift is over. Most of them are exactly where you would expect tired workers to be on a stormy Thursday evening, eating dinner, watching a movie, lying in their bunks. The wind is loud, but nobody's worried. Semi-submersibles are built for weather like this, and this one has been riding North Sea storms for 4 years. At approximately 6:30 in the evening, the men in the mess hall feel a sharp jolt, then a tremble running through the structure. Some of them later described a cracking sound. Within seconds, the floor is no longer level. The platform heels over, hard, and keeps going. 30 degrees and more, plates and trays sliding off tables, men grabbing at anything bolted down. What none of them can see in the dark water below is that one of the platform's 5 legs, leg D, is simply gone. Not damaged. Gone. The 6 steel braces holding that leg to the structure have snapped one after another in rapid succession, and the leg has torn away, taking the platform's balance with it. A 5-leg design that engineers considered robust has just become a 4-legged structure that was never meant to exist, tilting into the sea with 212 men inside. Here is the first thing that should stop you cold. The braces that snapped were massive steel tubes, and they did not fail because the storm was too strong. That storm was well within what the platform was built to survive. They failed because one brace, a member of the investigation called D6, had already been cracked for a very long time. And every wave, every gust, every workday for years had been quietly working that crack a little further around the circumference of the steel. On the evening of March 27th, the last remaining centimeters gave up. Everything after that took about 20 minutes. 20 minutes is not very much time, and the Kielland spent it capsizing in the dark, in a storm, with rain driving sideways across a deck now tilted like a playground slide. The evacuation that followed was chaos of the kind that safety engineers study frame by frame to this day. Of the platform's lifeboats, only one got away from the structure successfully in those conditions. Others were smashed against the platform by waves as crews tried to launch them, or could not be released properly as the list worsened. Men jumped into water cold enough to kill in well under an hour. Rafts flipped. The nearby Edda platform and rescue vessels pulled survivors from the sea where they could reach them. When the count was finally done, 89 men had survived. 123 had not. To this day, it remains the worst disaster in the history of Norwegian offshore operations, and one of the deadliest offshore accidents ever recorded anywhere. And then the engineers got to work. Because one question mattered more than any other. Steel braces on a 4-year-old platform do not simply snap in survivable weather. Something had cut that brace's strength long before the storm arrived. The answer would take investigators from the seabed of the North Sea all the way back to a fabrication yard in Dunkirk, France. And what they found there would quietly rewrite the rulebook for every welded structure floating on the ocean today. The Norwegian Investigation Commission recovered the failed structure and began the kind of forensic metallurgy that reads broken steel the way detectives read fingerprints. A fatigue fracture leaves telltale marks, beach marks, ripples frozen into the metal that show the crack growing slowly, cycle by cycle, over months and years. Completely different from the rough, sudden surface of steel that breaks all at once. The fracture faces of brace D6 told a clear story. This was fatigue. The crack had grown slowly around the circumference of the brace over a long period, until so little intact steel remained that the brace could no longer carry its share of the load. Then it tore, dumped its load onto the 5 neighboring braces, and they failed in sequence by simple overload, like buttons popping off a shirt one after another. So far, a classic fatigue failure. The real question was where the fatigue crack had started. And this is where the story stops being about big steel and starts being about something almost insultingly small. The crack had not started in the brace itself. It started at a fillet weld just 6 millimeters thick, about 1/4 of an inch. The little triangular bead of metal a welder lays where 2 pieces of steel meet. That weld attached a flange plate for a hydrophone mount, a holder for an underwater listening device used in positioning the rig. Understand what that means. The hydrophone was not structural. It held no weight. It was an accessory, an instrument bracket, the offshore equivalent of the little hook you screw into a wall to hang a picture. The tube for that instrument passed through the brace, and the small weld holding its flange to the brace had been made poorly into material with weak properties through its thickness, leaving high residual stresses locked into the joint. The Commission's cumulative damage calculations later confirmed that the fatigue life of that little weld detail was simply inadequate for the loads the brace experienced. In plain language, the weakest point on a structure holding 212 human beings above the North Sea was the attachment weld for a listening device, and the design process had never treated that weld as something that could kill anyone. Why would it? It was not on the list of things that mattered. But the most damning evidence was not the weld itself. It was what the metallurgists found when they examined the crack surfaces under magnification. Paint. Traces of paint deep inside the fracture faces, on surfaces that should have been bare, freshly torn metal. Think about what paint inside a crack actually means. Paint is applied during construction, before a platform ever touches the sea. If paint flowed into a crack, then the crack was already open when the painters did their work. The steel around that hydrophone weld had cracked during fabrication in the yard in Dunkirk in 1976, before the Alexander L. Kielland was even delivered. The platform did not develop its fatal flaw out on the ocean. It sailed out of the shipyard on day 1 already broken, with a hidden crack sitting quietly under a coat of fresh paint. and it operated for roughly 4 years while fatigue worked that flaw around the circumference of brace D6. French experts examined the fracture for any sign that anyone had found and tried to repair the crack during those 4 years. Any trace of underwater repair work. They found none. Nobody had repaired it because nobody had ever looked. And nobody had ever looked because no inspection regime in force required anyone to examine the attachment weld of a non-structural instrument bracket. The inspections followed the rules, and the rules did not consider a picture hook capable of sinking a city block. Sit with that for a moment, because this is the shape of the pattern this entire video is about. 123 men died not because a rule was broken, but because the killer lived in a place where no rule existed at all. The storm was legal. The design was approved. The inspections were done as required. Every box was ticked, and the platform capsized anyway, because the thing that failed had been classified by everyone as too small to matter. Norway responded by tearing up its assumptions about offshore structures, and we will come back to exactly what changed, because those changes are part of the answer to our opening question. But before that answer makes sense, you need to see the second disaster, because almost exactly 2 years later, on the other side of the Atlantic, another crew on another semi-submersible ran into the same invisible pattern in a completely different form. Their platform was the largest and most advanced drilling rig on Earth. A machine so massive that people who worked on it repeated the same word the newspapers used about a certain ocean liner 70 years earlier. Unsinkable. It would be destroyed by a window. The Ocean Ranger was the pride of its generation. A semi-submersible drilling rig so large it was billed as the biggest in the world, designed to drill in deep water, in brutal conditions, anywhere on the planet, and rated to ride out storms that would shut down lesser rigs. In February 1982, it was drilling an exploration well on the Grand Banks off Newfoundland, Canada, in some of the most violent winter seas on Earth. Water cold enough that an unprotected human body loses useful function in minutes. On board were 84 men, many of them young Newfoundlanders on their first industrial job, working for the drilling contractor and the operator on a rotation just like every offshore worker before and since. The rig had weathered Atlantic storms before. Among crews and families on shore, its size and reputation carried that dangerous word again, unsinkable, and the men aboard had every reason to believe the engineering behind it. On February 14th, Valentine's Day, a winter storm tracked across the Grand Banks with hurricane-force gusts and waves that grew through the day into moving walls of water. The Ocean Ranger and 2 other rigs drilling nearby all hung on through the same storm. In the early evening, one enormous wave, larger than the rest, slammed into the rig. And here the chain begins with a detail so ordinary it is almost embarrassing to say out loud. The wave broke a port light, a window, a round pane of glass in the ballast control room, the compartment housing the electronic panel that controlled the rig's trims and stability. Set low in one of the rig's columns, seawater came through the broken window and sprayed across the ballast control console, the electrical brain that opened and closed the valves managing seawater ballast in the rig's pontoons. On the panel, lights began to flicker. Valves that no one had commanded appeared to open and close on their own. The crew of a nearby rig, the Sedco 706, listening to the Ocean Ranger's internal radio traffic that night, overheard the crew discussing the broken glass and water in the ballast control room, and then heard something more unsettling. Talk of valves opening by themselves. Now put yourself in that control room, because what happens over the next several hours is not a story about cowardice or laziness. The men cleaned up the water, dried what they could, and believed the situation was under control. But a console that has taken seawater into its circuitry is no longer telling the truth, and it is no longer reliably obeying commands. The Royal Commission that later spent 2 years reconstructing this night concluded that the console suffered an electrical malfunction from the seawater, and that the crew, faced with a panel they could no longer trust, did not fully understand the ballast system they were fighting. And there was a reason they did not understand it. No regulation in force required rigorous, certified training in ballast control for the men holding those jobs. The industry assumed competence would come with experience. The panel had a manual backup mode, a way to actuate the valves directly by inserting metal rods into the solenoids. And investigators found evidence the crew resorted to exactly that, working brass rods into a system whose logic they had never been formally trained on. In the dark, in a storm, with the rig beginning to misbehave beneath them. Every action they took made sense to them at the time. Some of those actions were almost certainly opening valves that they believed they were closing. Through the night, the rig developed a list toward the bow. First slight, then unmistakable. 10 to 15 degrees down at the forward end. And that list activated the next hidden flaw. One that had been built into the rig from the start and had nothing to do with the storm. In the rig's forward columns were chain lockers, compartments holding the massive anchor chains, and their openings were not watertight. On an even keel, that hardly mattered. But with the bow pressed down, the sea reached openings it was never supposed to reach. And water began pouring into the chain lockers, adding weight exactly where the rig could least afford it. Pulling the bow down further, which flooded the lockers faster. Naval architects have a phrase for this kind of self-feeding failure, progressive flooding, and it is one of the most merciless processes in marine engineering. The Royal Commission identified it precisely, flooding of the chain lockers in the forward columns, after a list the crew could not correct, with a compromised console and a system they could not confidently control by hand. In the first hour of February 15th, the Ocean Ranger transmitted a mayday reporting a severe list and requesting immediate assistance. A short time later came the final transmission. The crew was going to the lifeboats. Think about what abandoning a rig meant that night. Waves tens of feet high, wind screaming, air and water both near freezing, in darkness. The life-saving equipment and the training to use it were, in the Royal Commission's later judgment, inadequate for those conditions. At least one lifeboat got away with men aboard. A standby vessel, fighting the same seas, reached men in the water and got close enough to a capsized lifeboat to throw lines. Close enough for the crews to see each other's faces. Not one man could be pulled from the water alive. Not one of the 84 was wearing an immersion suit, the insulated survival suit that keeps a body alive in freezing water because nothing required suits to be on board. And testimony gathered afterwards suggested many of the men died within minutes of entering the sea. Sometime in the early morning hours, the Ocean Ranger, largest drilling rig in the world, rolled over and sank. All 84 men died. Only 22 bodies were ever recovered, and the autopsies said the same thing for each: hypothermia and drowning. The sea did not even leave the rig behind as evidence. It went down in about 80 meters of water, taking most of its answers with it. The Royal Commission on the Ocean Ranger Marine Disaster, chaired by Chief Justice Alex Hickman, worked through the wreckage of that night, finding by finding, and the shape of what it found should sound familiar to you already. The rig sank because a window broke. Because a window that guarded the single most critical control room on the vessel was just a window, not a reinforced, storm-rated barrier with a deadlight cover treated as a piece of safety-critical equipment. It sank because the console behind that window had never been designed or protected on the assumption that the sea might reach it. It sank because the men operating that console had never been given formal ballast control training, because no rule on Earth said they had to be. It sank because chain lockers were left open to the sea on a vessel whose survival depended on watertight integrity. And the men died in the water because the concept of requiring an immersion suit for every worker on a winter ocean had not yet been written into any binding requirement for that operation. 5 separate gaps, and not one of them was a violation. A window, a panel, a training syllabus, a locker opening, a survival suit. Every one of them lived in the same regulatory shadow where the Kielland's quarter-inch weld had lived. The category of things nobody had classified as capable of killing everyone on board. 2 rigs, 2 years apart, 207 men, a weld and a window. If this were a coincidence, the pattern would stop there. It does not stop there, because 2.5 years after the Ocean Ranger went down, on a warm production platform off the coast of Brazil, a crew facing a blowout and a fireball did what every safety briefing on the planet told them to do. They did not panic. They mustered. They boarded their designated lifeboat, exactly as trained. And the lifeboat itself, the one machine on the platform whose only job is to save lives, killed 36 of them in a single moment. August 16th, 1984. The Campos Basin, offshore Brazil, the oil province that turned the country into a serious petroleum producer. The Enchova Central platform, operated by Petrobras, the Brazilian state oil company, is running production operations the way it has for years, with hundreds of workers aboard. Unlike the North Sea and the Grand Banks, there is no monster storm in this story. The weather is not the enemy today. The enemy is coming up from underneath, through the well itself. During operations that day, a well gets away from the crew, a blowout, high-pressure gas escaping control, and finding, somewhere on that platform, the one thing pressurized flammable gas always eventually finds: an ignition source, the gas lights. A fireball tears through part of the platform, and suddenly hundreds of men are in an offshore worker's oldest nightmare, standing on a burning steel island with nowhere to go but the ocean. And here is the part that separates Enchova from almost every other disaster in this series. The evacuation started the way it was supposed to. Workers moved to their muster stations. They boarded lifeboats. The system on paper was working. One lifeboat, loaded with men, began its descent toward the water on its davits, the crane-like arms that lower a boat down the side of a platform. Then the lowering mechanism failed. The boat jammed partway down, hanging above the sea, and then its stern support gave way. One end let go while the other held, and the boat swung and hung vertically, nose down, pouring its passengers toward the sea and then falling with them, dropping the remaining 10 to 20 meters, 30 to 60 plus feet, into the water below. 36 men died in and around that single lifeboat. They had done everything correctly. They had followed every instruction, boarded the right boat in the right order at the right time, and the equipment designed for exactly this moment had killed them during exactly the emergency it existed for. Elsewhere on the platform, 6 more men, seeing the fire and with the boats now either gone or untrustworthy, made the other choice available to a man on a burning platform. They jumped from 30 to 40 meters up, roughly 100 to 130 feet, the height of a 10-story building, into open water. The impact from that height is not survivable in practice, and none of the 6 survived it. 42 men died at Enchova that day, and not one of them died in the fire. Every single one died evacuating, betrayed by a hook, a davit, a mechanism, the small mechanical details of the escape system itself. Let the weight of that land properly. After Kielland, the industry learned that a bracket weld could sink a platform. After Ocean Ranger, it learned that a window could. Enchova taught the most bitter lesson of the 3. Even the rescue equipment itself lived in the blind spot. A lifeboat looks like safety. It is painted safety orange. It exists only for the worst day of your life. And yet, in 1984, the mechanisms that released and lowered lifeboats, the hooks, the davit systems, The load paths that held a boat full of human beings over a long drop were engineering details that no rigorous, universally enforced offshore standard was stress testing under realistic emergency conditions. Boats hung in davits for years, painted and repainted, lowered empty during calm water drills if they were lowered at all, and the industry told itself they would work when needed. It took decades of accumulated failures, at Enchova and in dozens of smaller incidents across the world's oceans, where lifeboats fell, hooks released prematurely, or mechanisms jammed during drills, before international rules forced the redesign and rigorous testing of these systems. The pattern held for the third time. The killer was small, mechanical, and officially invisible, and this time, the pattern had claimed the one machine whose entire purpose was to interrupt it. Now, if this were an ordinary disaster documentary, this is where the story would end, with the count at 249 and the pattern established. But Enchova has a second act, and it is the reason this episode exists. Because the same platform, Enchova Central, the same steel island in the same Brazilian ocean run by the same company, blew out again 4 years later. And what happened the second time is the closest thing industrial safety has to a controlled experiment. April 24th, 1988. Enchova Central is being converted, its wells transitioning from oil production to gas. During work on one of the platform's 21 wells, control is lost again. Another blowout, and this one turns violent in a way the 1984 event never did. The escaping pressure physically ejects drill pipe out of the well, launching steel up through the platform, and the flying pipe strikes one of the platform's legs. The impact throws sparks. The sparks find the gas cloud. Enchova ignites for the second time in 4 years, and this fire is worse, far worse, than 1984. It does not burn for hours. It burns for 31 days. A month of continuous fire, fed from the reservoir itself, hot enough and long enough that the top sides are wrecked beyond saving. The platform is eventually declared a total loss, measured purely in hardware, in destruction, in the raw energy released. The 1988 Enchova disaster is the bigger catastrophe by an enormous margin. The 1984 fire damaged a platform. The 1988 fire erased one. Here is the question this entire video has been building toward. In 1984, on this platform, a fire killed 42 men during the evacuation. In 1988, on the same platform, a worse blowout and a monstrously worse fire, 31 days of it, killed how many? Count them. 0. Not one fatality. Hundreds of workers came off Enchova Central in 1988, every single one of them alive. In an evacuation aided by a flotel positioned alongside, while the platform behind them burned down to scrap. Same ocean, same operator, same industry, worse disaster. Every life saved. Whatever changed between August 1984 and April 1988, it was not luck. Because luck does not scale to a 31-day fire. And it was not a gentler emergency, because the emergency was more violent in nearly every measurable way. Something structural changed in how human beings got off that platform. In the machinery of escape, in the procedures, in what had been inspected, tested, and rehearsed after 42 coffins made the cost of the old blind spot impossible to ignore. What changed is the answer to the question I asked you in the first minute of this video. What do a 1/4-inch weld, a broken window, and a lifeboat hook have in common? You have now seen all three do their killing. You have seen that all three were legal, inspected, approved, and invisible. The final part of this story is what the industry did about it. The standards that were written in the blood of those 249 men. Why those standards are the reason a 31-day fire produced 0 funerals, and why, despite all of that, you have almost never heard anyone talk about them. That silence, it turns out, is not an accident either. It is the whole point. Start with Norway, because Norway's answer to the Kielland was the most radical. The Commission's finding that a fabrication crack had hidden under paint for 4 years in a weld nobody was required to inspect destroyed a core assumption of structural engineering offshore, the assumption that only load-bearing members matter. The reforms that followed rewrote how floating structures are designed and inspected, not just in Norway, but in the class rules and international codes that govern rigs everywhere. Fatigue design stopped being a calculation applied only to primary structure and became a discipline applied to attachments, penetrations, brackets, the welded-on hardware that had been beneath consideration, because Kielland proved that a crack does not care whether the engineer classified its starting point as important. Redundancy requirements tightened so that the loss of a single brace could no longer remove a leg and capsize a platform full of sleeping workers. And non-destructive examination, the family of inspection techniques that finds cracks the eye cannot see. Ultrasonics, magnetic particle, radiography, expanded its reach into exactly the kind of secondary welds that killed 123 men. Today, when an inspector spends an afternoon running a probe over the attachment weld of a sensor bracket that holds no structural load at all, and a new hand asks why anyone bothers, the answer is a 5-letter Norwegian name that inspector may never have heard. That inspection is the Kielland's tombstone, translated into procedure. Canada's answer to the Ocean Ranger was just as direct, and you can still read it in the law today. The Royal Commission's recommendations poured into the International Rulebook for mobile offshore drilling units, the IMO's MODU Code, strengthening exactly the points that had failed on the night of February 15th. Stability standards, watertight integrity, the protection of ballast control systems, and critically, the training of the people who operate them. Ballast control stopped being a job you learned by watching and became a certified competency because the Royal Commission had concluded in writing that the crew's inability to understand and control that system was a direct cause of 84 deaths. And then there are the suits. Under the Canada, Newfoundland, and Labrador offshore regulations in force today, an operator must provide immersion suits conforming to the national standard, KDN ICGSB 65 Norsktimum 16. And on a manned installation, the requirement is not 1 suit per worker. It is 200% of the people on board, with 1 suit adjacent to every single bed and the rest distributed among the evacuation stations. 2 suits for every man, positioned so that no one has to cross a burning or flooding platform to reach one, on the exact stretch of ocean where 84 men once went into the water with none. Read that regulation with the Ocean Ranger in your mind, and it stops being bureaucracy. It is a list of everything that killed those men, inverted item by item into requirements. The lifeboats took longer, which is its own quiet scandal, but the change came. The International Rules for Life-Saving Appliances, SOLAS, and its Life-Saving Appliance Code progressively forced the redesign, testing, and re-examination of the release hooks and launching systems that failed at Enchova and kept failing around the world for years afterward. Modern requirements demand release mechanisms engineered so that a hook cannot let go under load accidentally, mandate realistic launch testing and maintenance regimes, and treat the entire load path of a davit-launched lifeboat, the winches, the falls, the hooks, the supports, as safety-critical equipment subject to inspection and overhaul, not as painted scenery to be admired during drills. In Norway and on many installations worldwide, the industry went a step further and adopted free-fall lifeboats, boats that do not descend on wires at all, but launch clear of the platform in seconds. an entire technology whose adoption was accelerated by the accumulated body count of David systems that jammed, tipped, and dropped the people they were built to save. And here is the connection almost nobody makes out loud. When hundreds of workers came off the burning Enchova Central alive in 1988, while the 1984 evacuation of the same platform had filled 42 coffins, the difference was not courage, and it was not chance. It was that the machinery and management of escape had been overhauled in the shadow of the first fire. The 1988 evacuation is what it looks like when the lesson actually gets institutionalized. A platform can be a total loss. The crew does not have to be. And the United States has its own version of this story, one that predates all three disasters and proves the pattern from the opposite direction. In June 1974, the American Petroleum Institute published Recommended Practice 14C, a methodical system for analyzing every process component on an offshore production platform. Every vessel, every flow line, every piece of equipment holding pressurized hydrocarbons, and specifying the sensors and shutdown devices that must guard each one. High and low pressure sensors, level sensors, shutdown valves, all feeding a platform-wide emergency shutdown system with a defined logic. Federal regulators incorporated it by reference into the offshore rules, which means that on a Gulf of Mexico production platform, that document is not advice. It is law. Nobody makes documentaries about API RP 14C. There has never been a movie about a low-pressure sensor, and that is precisely the point. Because every single day, on hundreds of platforms, some sensor somewhere trips, a valve swings shut, a well isolates itself, and a sequence that could have become a fireball becomes a maintenance ticket instead. The disasters that standard prevents do not have names, because they do not happen. That is what a working standard sounds like. Silence. Which brings us finally all the way back to the paint. What do a 1/4-inch weld in Norway, a broken window off Newfoundland, and a lifeboat hook in Brazil have in common? Here is the full answer. Every one of them killed because it sat in the gap between what engineers had imagined and what the ocean actually did. Not one of the three was covered by a standard on the day it killed. And not because regulators were lazy or companies were uniquely evil, but because every safety system ever built shares the same weakness. It can only protect against what someone, somewhere, decided was worth writing down. The weld was not written down because the bracket held nothing. The window was not written down because a window is not a ballast pump. The hook was not written down because lifeboats were the answer to danger, not a source of it. 249 men died inside those three assumptions. And the reason nobody talks about the standards that came afterward, the fatigue rules, the MODU Code, the immersion suit percentages, the hook redesigns, the sensor logic of RP14C, is the same reason nobody thanks a seatbelt after an uneventful drive. A standard that works produces nothing. No fire, no headline, no film, no anniversary. The Kielland gets documentaries. The rule that has kept every Pentagon-braced platform since the Kielland afloat gets a paragraph in a class society manual that only inspectors read. We talk about disasters because they are visible, and we stay silent about standards because their entire product is the absence of an event. The standards nobody talks about are, by that exact measure, the ones doing their job. So here is what this means for you. On your shift this week, because this pattern did not retire in 1988. Somewhere on your site right now, there is a bracket weld nobody classifies as structural. A window or cable penetration guarding something critical. A hook or a latch on a piece of rescue equipment that everyone assumes will work because it has never been asked to. When your inspection plan sends you to look at something that seems too trivial to inspect, that trivial thing is on the list because its twin already killed people. When a drill makes you actually operate the escape equipment instead of pointing at it. Run the drill like it is 1984, and your debit is the one with the tired stern support. And when you find yourself thinking that some small, boring detail is beneath your attention, remember that the most expensive object in the history of Norwegian offshore oil was a 1/4-inch weld, and the paint inside it proved that 4 years of humans walked past it every day, every one of them certain that somebody else had it covered. The question was never whether the small things can kill. The question is whether they get found by an inspector or by a coroner. And the standards nobody talks about exist to make sure it is the inspector. If this series changed the way you look at a platform, this is the moment to act on it. Subscribe to Eric the Workplace Safety Guy, because this channel does one thing. It takes the rules everyone ignores and shows you the bodies they are built on. So you learn this the cheap way, instead of the way those 249 men did. This episode closes the platform series, but the pattern we just uncovered does not stop at the waterline. The next investigation goes on shore, into a single OSHA rule, 14 elements long, the rule that is quietly the only thing standing between a normal Tuesday and a mushroom cloud at every refinery and chemical plant in the country. The refinery that ignored it lost 15 workers in a single morning. That story and that rule are next. Do not learn it the expensive way.